Hello everyone again. Good day. Let us continue with our classes on programming, and we are still looking at the first chapter, part 1, and we are concerned with variables and the roles of variables in programming. Now, as we agreed earlier, we said that for every chapter we will follow 5 steps. One is to look at the worked examples, codes, where a text written in the form of program will be explained. Then we shall compile that text in a compiler to see how the computer reacts when it reads the particular program. Then we must visualize every piece of program so that every statement must be analyzed and visualized in order to understand what is happening inside the computer. So the first visualization will be based on physical models where containers of any type can be imagined, and these will be mimicked as computer memory to explain what is happening in the computer. So after looking at the compilation in the past video, let us look at the same program and visualize it using physical models. Now the program that was in question is this one here. So we shall visualize every action that takes place due to variable declaration, data feeding, data processing, and data outputting. So now, if we come to the drawing board, we can reproduce this program by understanding that the program contains libraries which are made of the standard include, IO, stream, and so forth. But then, as we agreed, the program starts at the int main statement, where a curly bracket opens, and in this particular juncture, we can start declaring variables. So the first variable that was declared was int x, then followed by int y, followed by int z. These are 3 statements which entail variable declaration. After variable declaration now follows data feeding. So the variable x is fed with data, let's say 5, and variable y is fed with data, let's say 7, and then the data which is in variables is now being processed, and the answer is sent to z, that z equals to x plus y, and then we output cout z, and then we say return 0 for int main. So this is more or less the program. Now let us visualize it by using what we call physical models. Consider the computer memory to be similar to a bank of containers such as empty cups. So this one, you can consider this to be the computer RAM. This is computer random access memory. So if this is so, it means before declaration, all these are empty. There is nothing inside memory. Now, after declaration, you have a situation similar to this, whereby these originally empty cups or empty containers One is labeled X because of this statement, another is labeled Y because of this statement, and for this statement, another is labeled Z, while the rest will remain empty. Now, these are already reserved. It means nobody can occupy them, but they don't have content yet. Nothing is inside. However, they are reserved. Reserved. Then, when it comes now to data feeding, you find that the cup X will have 1, 2, 3, 4, 5. The cup Y will have 1, 2, 3, 4, 5, 6, 7. And then the cup Z, after this statement, will have what is in X added to what is in Y, that will come to Z. So here we shall have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, and it will be containing at least 12 pebbles as we agreed. So this is cup Y, not Y here. So this is Y and this is Z. So when we come to the statement C out Z, the counting is done here where number 12 is reflected on the screen. So as far as we are concerned, this is the way we can mimic the concept of variable declaration and data inputting and data processing using what we call physical models. You can take any kind of container like let's say cups or whatever, then you may consider them to be the memory of the computer, which will have to be labeled, and then you input data into it, and that data is processed, and again that data is stored inside a variable. But for now, this is as far as physical visualization can be concerned. And for this, I could say thank you and bye.